In this video, you're going to create your HTTP post route for adding new to-dos. Before we dive into that, we're going to take a quick second to refactor everything we have in server.js because it doesn't really belong here. We have database configuration stuff, which should live somewhere else, and we have our models, which should also live in separate files. The only thing we want in server.js is our express route handlers. To get started, inside of the server directory, we're going to make a new folder called db. And inside of the db folder, we'll make a file where all of this Mongoose configuration happens. I'm going to call that file mongoose.js. And all we need to do is take our Mongoose configuration code right here, cut it out, and move it over into mongoose.js. Now we do need to export something. What we're going to export is the Mongoose variable. So essentially, when someone requires this file, they're going to have Mongoose configured and they're going to get it back. They're going to get back the Mongoose variable that comes from the library. Right here, I'm going to set module.exports equal to an object, and on that object, we'll set mongoose equal to mongoose. Now, as we know in ES6, this can be simplified. If you have a property and a variable with the same name, you can shorten it, and we can take things a step further and put it all on one line. Excellent. Now we have the Mongoose configuration in a separate file, and that file can be required right here. I'm going to pull off the Mongoose property using ES6 destructuring. Essentially, we're creating a local variable called mongoose equal to the mongoose property on the object. And that object is going to be the return result from requiring the file we just created. That's in the db directory, and it's called mongoose.js, and we can leave off that extension. Awesome. Now that Mongoose lives in its own place, let's do the same thing for to-do and user. This is going to happen in a new folder in server called models. Inside of models, we're going to create two files, one for each model. I'm going to make a new file called todo.js and a new file inside of models called user.js. And we can take the models from here and simply copy and paste them into their appropriate files. Once the model's copied, we can remove it from server.js. I'm going to do the same thing with user, copying it into user.js and removing it from here. Now I'm also going to remove everything we have so far. All of these examples aren't necessary anymore. We can simply leave our Mongoose import statement up at the top. Now inside of these model files, there are a few things we need to do. First up, we call Mongoose model, so we still need to load in Mongoose. Now we don't have to load in the Mongoose.js file we created. We can load in the plain old library. Let's make a variable, call that variable mongoose, and we're going to require mongoose. And the last thing we need to do is export the model. Otherwise, we can't use it in files that require this one. I'm going to set module.exports equal to an object, and we'll set the to-do property equal to the to-do variable. This is exactly what we did over in Mongoose.js. And we're going to do the exact same thing in user.js. Inside of user.js, up at the top, we'll create a variable called mongoose, requiring in mongoose. And at the bottom, we'll export the user model. Module.exports, setting it equal to an object where user equals user. Awesome. And now all three of our files have been formatted. We have our three new files and our one old one. The last thing left to do is load in to-do and user. Let's make a variable using destructuring called to-do, setting it equal to require models /to-do, and we can do the exact same thing for user. Using ES6 destructuring, we're going to pull off that user variable, and we're getting it from the object that comes back from a call to require, requiring models /user. Excellent. With this in place, we are now ready to get going. We have the exact same setup, only it's been refactored, and this is going to make it a lot easier to test, update, and manage. The server.js file is just going to be responsible for our routes. And to get started, we're going to need to install Express. We've already done that in the past, so over in the terminal, all we need to do is run npm I, followed by the module name, which is Express. We'll be using the most recent version, 4.14.0, and we're also going to be installing a second module. And we can actually type that right after the first one. There's no need to run npm install twice. This one is called body-parser. A body parser is going to let us send JSON to the server. The server can then take that JSON and do something with it. Body parser essentially parses the body. It takes that string body and turns it into a JavaScript object. Now, body parser, with an R on the end, we're going to be installing the version 1.15.2, the most recent version. I'm also going to provide the save flag, which is going to add both express and body parser to the dependencies section of package.json. Now I can go ahead and fire off this request, installing both modules, and over inside of server.js, we can start configuring our app. First up, we have to load in those two modules we just installed. As I mentioned, I like to keep a space between local imports and library imports. Right here, I'm going to use a variable called express to store the express library, require express. And we're going to do the same thing for body parser. A variable called body parser, setting it equal to the return result from requiring body hyphen parser. Now that we have this in place, we can set up a very basic application like we did earlier in the course. We're going to make a variable called app. This is going to store our express application. I'm going to set this equal to a call to express. Nothing new here. And we're also going to call app.listen, listening on a port. Now we will be deploying this to Heroku eventually. For now though, we're going to have a local port, port 3000. And we'll provide a callback function that's going to fire once the app is up. And all we're going to do is use console.log to print started on port 3000. Excellent. Now that we have this in place, we have a very basic server. All we have to do is start configuring our routes. And as I promised, the one we're going to be focusing on in this video is the post route. This is going to let us create new to-dos. Now, inside of your REST APIs, there's the basic CRUD operations. CRUD being create, read, update, and delete. When you want to create a resource, you use the post HTTP method, and you send that resource as the body. This means that when we want to make a new to-do, we're going to send a JSON object over to the server. It's going to have a text property, and the server is going to get that text property, create the new model, and send the complete model with the ID, the completed property, and completed at back to the client. To set up a route, we need to call app.post, passing in the two arguments we've used for every single express route, our URL and our callback function that gets called with the request and response objects. Now, the URL for a REST API is really important, and there's a lot of talk about the proper structure. For resources, what I like to do is use /to-dos. This is for resource creation, and this is a pretty standard setup. /to-dos is for creating a new to-do. Later on, when we want to read to-dos, we'll use the get method, and we will get from /to-dos to get all to-dos, or /to-dos some crazy number to get an individual to-do by its ID. This is a very common pattern, and it's the one we're going to be using here. For now, though, we can focus on getting the body data that got sent from the client. To do this, we have to use that body parser module. As I said, body parser is going to take your JSON and convert it into an object, attaching it onto this request object. Right here, we're going to configure the middleware using app.use, which we used earlier inside of our express section. As we know, app.use takes the middleware. If we're writing custom middleware, it'll be a function. If we're using third-party middleware, we usually just access something off of the library. In this case, it's going to be body parser.json, getting called as a function. The return value from this JSON method is a function, and that is the middleware that we need to give to Express. With this in place, we can now send JSON to our Express application. What I'd like to do inside of the post callback is simply console.log the value of request.body, where the body gets stored by body parser. With this in place, we can now start up the server and test things out inside of Postman. Over in the terminal, I'm going to use clear to clear the terminal output, and then I'll run the app node server server.js. The server is up on port 3000, which means now we can head into Postman. Now inside of Postman, we're not going to be making a GET request like we did in the previous video. This time, what we're going to be doing is making a POST request, which means we need to change the HTTP method to POST and type the URL in right here. That's going to be localhost 3000 for the port /todos. This is the URL that we want to send our data to. Now, in order to send some data to the application, we have to go to this body tab. We're trying to send JSON data, so we're going to go to raw and select JSON from the drop-down list on the right-hand side. Now we have our header set. You can see there's one header showing up right here. This is the content type header, letting the server know that JSON is getting sent. All of this is done automatically with Postman. Inside of here, the only piece of information I'm going to attach to my JSON is a text property. This is from Postman. Now that we have this in place, we can click send to fire off our request. We're never going to get a response because we haven't responded to it inside of server.js, but if I head over to the terminal, right here, you see we have our data. This is the data we created inside of Postman. It's now showing up in our Node application, which is fantastic. We are one step closer to actually creating that to-do. The only thing left to do inside of the post handler is actually create the to-do using the information that comes from the user. Let's make a variable called to do the thing we've done previously, creating an instance of a Mongoose model. We're going to set it equal to new to-do, passing in our object and passing in the values we want to set. In this case, we just want to set text. We're going to set text to request.body, which is the object we have here. And then we're going to access that text property like this. Next up, we're going to call todo.save. This is going to actually save the model to the database. And we are going to be providing a callback for a success case and for the error case. Awesome. Now, if things go well, we're going to be sending back the actual to-do, which is going to show up right here. I'm going to get the document. And right here inside of the callback function, I'm going to use response.send to send the doc back. This is going to give the user really important information, things like the ID and the completed and completed at properties, which were not set by the user. If things go poorly and we get an error, that's fine too. All we're going to do is use response.send to send that error back. Now, we'll be modifying how we send errors back a little later. For now, this code is going to work just great. We can also set an HTTP status. If you remember, HTTP statuses let you give someone some information about how their request went. Did it go well? Did it go poorly? All that sort of thing. You can get a list of all the HTTP statuses available to you by going to http://statuses.com. Here you can view all of the statuses that you can set. The one that's set by default by Express is the 200. This is if things went okay. What we're going to be using for an error is a 400. A 400 means there was some bad input, which is going to be the case if the model can't be saved. Maybe the user didn't provide a text property, or maybe the text string was empty. Either way, we want to send a 400 back. And that's going to happen right before we call send. All we're going to do is call status, passing in the status of 400. With this in place, we are now ready to test out our post to-dos request over inside of Postman. I'm going to restart the server over inside of the terminal. You could start this up with nodemon if you like. For the moment, I'll be manually restarting it. We're now up on localhost 3000, and over inside of Postman, we can make the exact same request we made earlier. I'm going to send it off, and what do we get? We get a 200. This is fantastic. It's the default status, which means things went great. Down below, the JSON response is exactly what we expected. We have our text that we set, we have the ID, which was generated, we have completed at, which is set to null, the default, and we have completed set to false, the default. This is brilliant. We can also test what happens when we try to create a to-do without the proper information. For example, maybe I set a text property equal to an empty string. If I send this along, we now get a 400, bad request. Down below, we have a bunch of validation code saying that the to-do validation failed. Then we can go into the errors object to get the specific error. Here we see the text field failed, and the message is path text is required. All of this information can help someone fix their request and make a proper one. Now, if I head over into RoboMongo, I'm going to refresh the collection for to-dos. Look at the last one, and it is indeed the one we created in Postman. The text equal to "This is from Postman." With this in place, we now have our very first HTTP endpoint set up for the to-do REST API. Now, I haven't talked exactly about what REST is. We're going to talk about that later. For now, we're going to focus on creating these endpoints. The REST version will come up a little later when we start adding authentication. With this in place, I want to give you a challenge. Your challenge is going to be to fire off a couple more to-do requests. Try to set some text for at least one more to-do. Make sure it shows up in the database as expected. If it does, great, you are done. Take a moment to add a few to-dos, pause the video, and when you're done, click play. That one should have been pretty easy. Over inside of Postman, we can add a few more to-dos. I'm going to add some right here. Charge my phone. I don't think I've ever needed to be reminded of that one. And we'll add take a break for lunch, because it's about 12:30 and I'm starting to get pretty hungry. Down below, we see the charge my phone to-do was created with a unique ID. I'm going to send off this one. And we see that the take a break for lunch to-do was created. Over inside of RoboMongo, we can give our to-dos collection a final refresh. I'm going to expand those last 3 items, and they are indeed the 3 items we created in Postman. Now that we have some meaningful work done in our project, let's go ahead and commit our changes. As you can see over in Atom, the server directory is green, meaning that it hasn't been added to Git, and the package.json file is orange, which means that it's been modified, even though Git is tracking it. Over in the terminal, we can shut down the server, and I always like to run git status to do a sanity check. Here, everything does look as expected. I can then use git add to add everything, followed by one more sanity check. Here we have our 4 new files in the server folder, as well as our package.json file. Now it's time to make that commit. I'm going to create a quick commit. I'm using the AM flag, which usually adds modified files. Since I already used add, I can simply use the M flag, like we've been doing in the course. Good message for this one would be something like add, post, to-dos, route, and refactor Mongoose. Excellent. With the commit in place, we can now wrap things up by pushing it up to GitHub, making sure it's backed up, and making sure it's available for anyone else collaborating on the project. Remember, creating a commit alone does not get it up on GitHub. You got to push that with another command. With that in place, it's now time to move on to the next video where you will be testing the route you just created. Stay tuned. I will see you then.